Let's talk about packets and protocols. As we saw earlier in this activity, data transmitted on the internet is broken into smaller chunks called packets and sent to their destination using the fastest route at the time of the data exchange. We also talked about how communication on the internet has to conform to a set of rules called protocols, which work together to ensure the data is transmitted successfully from its source to its destination. At low levels of network abstraction, the on-off state of electricity is transmitted along a wire. At high levels of abstraction, you receive an email, access a web page, or stream music. And in between, it's all about protocols and packets. The Internet Protocol is the underlying packet structure for data exchange over a network and is referred to as the network layer. It is responsible for addressing and routing each data packet. The first rule of the Internet Protocol is that every computer connected to the Internet must be assigned a unique identifier called an IP address. Another rule of IP requires that all IP packets conform to a specific structure. Each IP packet must contain a header as well as data referred to as its payload. The header contains metadata, which is information about the packet itself that's needed for its transmission. This includes packet length, the source IP address, and destination IP address. The payload contains the actual data that's being sent, like the content of an email, a web page, or a video. The payload also contains information pertaining to other protocols used in the data exchange process. As the Internet grew, the Internet Protocol changed over the years. Deployed in 1983, IP version 4, or IPv4, is still in wide use today. IPv4 uses a 32-bit address scheme, or 4 bytes that contain 8 bits each. This allows a storage capacity of 2 to the 32nd addresses, which equates to 4,294,967,296 unique IP addresses. That means IPv4 can provide just under 4.3 billion internet addresses. A common abstraction used to express an IPv4 address is the dot decimal notation. An IP address has 4 bytes. Each byte, or 8 bits of binary, is called an octet. Each octet in the IP address is converted to decimal. The 4 decimal numbers are separated by a period, referred to as a dot. Dot decimal notation is much easier for humans to deal with than binary. Due to the phenomenal increase of devices accessing the internet over the last couple of decades, the 4.2 billion addresses were not enough and IPv4 ran out of addresses. The solution was that IPv6, originally released in 1994, began to be used to fulfill this increased demand. IPv6 uses a 128-bit address scheme, allowing for 2 to the 128th additional IP addresses. In place of the 4 octets of IPv4, an IPv6 address contains 8 groups of numbers, each containing 2 octets or 16 bits. Groups are separated by a colon instead of a dot to distinguish them from an IPv4 address. In addition to the Internet Protocol, the network layer includes routers that connect networks together and oversee the routing of IP packets across the Internet. They use sophisticated algorithms to determine the fastest way to get them to their destination.